In this video, we're going to look at counting methods in section 3.5. Now, the simplest way to visually represent the multiplication principle, which is the first thing we're going to talk about, is by using a tree diagram. Okay, so the multiplication counting principle and tree diagrams. Let's look at an example to see how that would work. So let's say a person walks into a restaurant for a 3-course dinner, and there are 4 different salads, 3 different entrees, and 2 different desserts to choose from. Assuming the person eats a salad, an entree, and a dessert, how many different meals are possible? All right, so let's first fix this. Dessert has 2 S's, and we can look at it with a tree diagram. Now, if we look at the 4 different salads, that would start like this. 4 different salads, then 3 different entrees. So for the first salad, you have 3 different ways you could choose an entree. For the second one, the same thing, and the third and the fourth salad, kind of poorly drawn. And then after that, there are 2 desserts on each choice that has already been made. So once we get done, what we have is a tree diagram. And the number of branches you have at the end is how many different choices there are. So the other way to do this is to use the multiplication counting principle, in which we would say 4 salads times 3 different entrees times 2 different desserts leaves you with 24 possible combinations. So let's explicitly state what that means down here in the multiplication counting principle. So our multiplication counting principle states that if there are n sub 1 ways to choose the first item, n sub 2 ways of choosing the second item after the first item is chosen, and n sub 3 ways of choosing the third item after the first 2 have been chosen, and so on, until there are n sub k ways of choosing the last item. Then the total number of choices is given by n sub 1 times n sub 2 times n sub 3 times all the choices times the last one. Let's look at the number of ways 4 people can line up. So in example 2, you've got 4 people, person A, B, C, and D. And let's say you want to choose the first person in the line. You could choose from any 4 of them. So there are 4 ways to choose the first person. Then once that person's been chosen, there are 3 ways to choose the next person. To choose the third person, there would be 2 ways, and to choose the last person, there'd only be 1 left. So in this case, similar to above, there would be 24 different lineups. So what we just did up here is another concept called factorial. So what we just did here was 4 factorial. And what a factorial means, it's written like this, is you take that number times the number 1 less than it, times the number 1 less than that, all the way down to 1. So let's do that in a couple of examples here. Now, there is a caveat here, which is very interesting, and that is that 0 factorial equals 1. Why? Well, it has to be that way because in some of the formulas, when you have a number underneath, let's see, n minus r, underneath in the denominator, you get 0 factorial. And if that's the case, you can't have 0 in the denominator. So brilliant mathematicians have decided that 0 factorial equals 1. All right, let's look at these examples here where we want to find 5 factorial. 5 factorial, according to our definition, of course, would mean 5 times 4 times 3 times 2 times 1, or 120. And 8 factorial. Well, let's see how to do factorials on Desmos and on our calculators, because this can get pretty long. Let's pull up Desmos. You can see we have Desmos up now. And to do 8 factorial on Desmos, what we want to do is hit 8. And then if we go to function, we can find factorial right here. We just type that, and you get 40,320. Now, of course, you could have just multiplied it out, but that is a speedy way to do it. I will link in the videos here how to find factorials and other probability functions on your Texas Instrument calculator in a separate video. All right, let's go back to our notes. So over here, we just identified that 8 factorial is 40,320. All right, let's use our multiplication counting principle for license plates in example 4. Example 4. So this example says some plates in Arizona consist of 3 digits followed by 3 letters. So digit time digit. So using the multiplication counting principle, we'd multiply them. And then by 3 letters, we'll call that letter times letter times letter. Let's see how many different types of license plates are possible if both the digits and the letters can be repeated. So let's identify this. For digits, you have the number 0, 1, 2, 3, all the way out to 9, which means there are 10 digits to choose from. So if digits and letters can be repeated, then for the first 3 spaces in our license plate, you go 10 times 10 times 10 to represent all those digits. Similarly, if letters can be repeated, there are 26 letters of the alphabet, so that would be 26 times 26 times 26. So if we do this on our calculator, we can go 10 to the third times, oops, we didn't want that. Let's go 10 to the third times 26 to the third. And we get 17,576,000. That is a lot of license plates. Let's look at our next example. It says the letters can be repeated, but the digits cannot. So if we're looking at the first 3 digits, if they can't be repeated, we'd have 10 to choose from for the first one, but then only 9 from the second and 8 from the third, because they cannot be repeated. And then for the last 3 letters, they can be repeated. So we'd have, again, 26 times 26 times 26. Using Desmos to calculate this, we get 10 times 9 times 8 times 26 to the third, which looks like it's 12,654,720. Let's put that up here. All right, I'm going to ask you guys to try C and D, pause the video, and we will look at them together when you're done. So in C, where the first digit cannot be a 0, that means you only have the numbers 1 through 9 to choose. So there are only 9 choices for the first digit. But then letters can be repeated. So for the second and third digit, you could have 10. Then with the letters that can be repeated, you'd have 26 to the third, giving you 15,818,400. If you look at D, where it says neither digits nor numbers can be repeated, it's just 10 times 9 times 8 for the digits, and then 25 times 26 times 24 for the letters, giving us 11,232,000. Oops. All right. In our next video, we are going to start on permutations. Thanks for watching.